All right, so today we're going to be talking about JSON and APIs. It's kind of like this notebook kind of split into two sections, one talking about JSON and then about APIs later on. If you've noticed, we've skipped topic 8. So topic 8 we'll talk about not next week, but the week after, just because I want to give you all a little bit more time to sit with our project. I would say that I mentioned that the project does focus on like topics 1 to 6. So for topics 7 through 10, I do think that if there was any topic that you could incorporate into this project, it would be this topic. I'll explain like what are the ways that you'll be able to do that. Okay, so the first thing we're going to dive into is JSONs. So JSONs, I think in like some of the labs, they might have just been there, but without like much context on what JSON is. So really quickly, JSON is a file type. So, you can literally have like .json files. So if you take a look in the repo, well, this is not the repo, but there is a .json file. And if I click into it, it looks like this. If you see, it kind of looks like a dictionary. It pretty much is the same as a dictionary. You have your curly brackets and it is in key value pairs. And JSONs are very, very popular data types. And why JSONs and APIs are lumped together is because later we'll see when we query an API, it usually comes in a JSON file format, i.e. like a giant dictionary. So we'll get into this in a little bit, but just also wanted to show you all, similar to what we were talking about yesterday with SQL, JSON files also can have schemas, right? We mentioned like the main data types are like, something that you can express as like a table form. Something in JSON is usually less appropriate for tables, but the key values really lend themselves to, you can be a little bit more flexible. So like, let's say in one entry of, I don't know, in this example, this is Yelp's example, I think. No, this is New York Times example. So let's just say that this was storing data on articles. An article could have multiple authors or multiple authors or writers. And putting that information in a table is sometimes hard because sometimes you have like different numbers of writers or contributors to a certain article. So therefore, sometimes it's just more appropriate to have it in this format where you can have that variability in like length, especially. Also, maybe some articles you have certain data that other articles don't have. Like maybe, let's see, maybe like some articles have multimedia content and some don't. So with JSON file formats or dictionary file formats, you have the flexibility of like, all right, if there's no multimedia for this one article, then we don't need to have the key there. It saves some space. So that's like, I would say the two most common data types that you would deal with are, table format like SQLs or like CSVs or JSON file formats. As you can see here, this is a schema. So it does have the structure of a dictionary, but it's really just, placeholder data of like, what your dictionary or what your results should look like. You can see there's like, it's pretty nested. You have like response as a key, and within that you have docs as a key, and docs seems to be like a list here, and like a list of these smaller dictionaries. Very, very common to be very, very nested. So yeah. Know that that's something you will get used to working with over time. As you can see, this file is actually what I have saved here, which I also put in the study group repo. So let's read that file. So to do that, there's a JSON library that does this for us. And really the only thing we're using the JSON library for is opening up the file. And you might have seen something that looks similar to this in a couple places. I think this is one way to like open like TXT files. You can technically read CSV files this way as well, but this is just Python's way of opening a file. Basically, you give it the file name, and then R stands for read. Later, we'll see that there's a write option. And so when you have this as a variable, this basically has this like open object, and then this actually loads the data. So when we assign the loaded data into the variable data, we can then take a look. So just printing some information, I am a big proponent of exploring your data through print statements or through like, even if they're data frames, you do like your .head, .info, .describe, just to get as much information as you can without, actually loading everything up on your Jupyter notebook. As you get bigger and bigger files, whenever you have very large outputs on your Jupyter notebook, if you find your computer running a little bit slower, or you find your cells just taking a while to run, sometimes the scrolling up and down will be a little bit like lagged out. That's why if you have like a lot of output, you want to kind of not have that. So just some really, really surface level exploration. The type of data is a dictionary. So because, JSONs match dictionary structures. And then let's just take a look at the first level of keys. There's like a status, copyright, and response. So this schema is actually an image taken from the New York Times API documentation, and they don't have the status and copyright keys here, but it comes in the result. If we just take a really, really quick look and see, like, are we going to use the information in status or copyright? So you can see status just says, okay, it was a successful data pull. If we look at copyright, likely it's just, copyright info, not super important as well. And then this is going to take up a bit of space, but, all of our information is under the response key. This is actually quite typical. Sometimes like the less nested keys that have not as relevant information would include things like the status code, maybe actually, yeah, exactly what they had, the copyright information. We'll see here, there's also metadata, but metadata in this case is actually nested somewhere here as well. Yeah, at the very bottom, you can see the metadata. All right, so it's very, very normal to do like a bunch of exploration at this point. So as an example, if I know that, okay, the stuff that I want is going to be in response, what are the keys in response? Okay, docs, and then this meta. We've kind of like infer, and honestly through experience, we know that meta probably doesn't have information that we're going to use unless you want to use the metadata. So all right, let's take a look at docs then. So docs, it's really just like a bunch of like trial and error and rerunning a cell. All right, the type of docs is a list. Sweet. So if it's a list, that means we can take a look at, actually, before looking at that, we can maybe look at the length. It's all right, we got 9 items in this list. Since there's 9 items in this list, let's maybe take a look at the first one. First one looks to be a dictionary. This output is not so long. Cool, good to know. Good to know that in docs, very likely it's gonna be like 9 items that look like this. And if you want to just do a quick check, maybe a random number between 1 to 9, there we go. All right, so this is what we kind of did already. We looked at the first list element in the docs. Let's take a look at the keys. You can see here we have the web URL, snippet, abstract, source, multimedia, keywords, headline, stuff like that. If I just set this to a variable, just so I don't have to keep typing this over and over again, we can see that docs is a list of length 9. We did that above already. And then this is where you can start maybe looping through and putting together the data in the format that you want. One really quick way to do it for docs in docs, for doc in docs, just print the headline. Maybe I want to get the headline info. Through doing this, oh, great, we have more nested dictionaries. That's fine. We know how to, we know how to work through nested dictionaries now. So to print the headlines themselves, because this one's pretty small, it's kind of easy to take a look at. You can sort of see that the main headline that we want seems to be under the key main. So just to edit it, for doc in docs, print just the headline. So cool, awesome. We have just a bunch of headlines. So this is just us extracting data from a JSON file. Definitely worth spending the time to, familiarize yourself with your large dictionary. Absolutely okay. Just throw like print statements here and there, find the type of things, find the length of the list of things, all in good exploration. Okay. So here what we've done, we've just printed these headlines, but in just printing headlines, not the most important, not the most feasible way to have our information. So let's talk about how we can transform this into data types that we know how to work with. And the data type that we have been working with more is pandas. So although I did say that that data usually comes in either table form or dictionary form, pandas just has a lot of really strong functionality to, that broadcasting of functions. We are just getting more familiar with like all the pandas methods that we can do. So why not try and put it in pandas if we can? And we'll take a look at some of the issues that arise. So let's just quickly import pandas because I didn't already. What's pretty neat is pandas is decently good at coercing things into a data frame. So data response docs is here. Actually, I think I can also use the variable docs, turn that into a data frame. You can see that, okay, not bad, not bad. I have the URL, I have snippet, abstract, the source. The only downside is, if you remember, this dictionary was pretty nested. Anything on this first level of dictionary turns into a column. But then you see, remember, we had the headline here. If I just had the headline, this is what was in each headline. So as a result, what's in this data frame is actually a dictionary, which is honestly, depending on your purpose, okay or not. I think for me, ideally, I want to have like my actual headline. So if I take a look at headline is my nested dictionary, which is not what I want. And at this point, there are many different ways that you can go about this. I have some code in like breaking out the nested data, but I do think it's a pretty common process to go through, especially if you're getting data from an API. So write your own version of your function. Feel free to use this as well. I mean, it really doesn't matter. But if you can think of like a more efficient way to do this, by all means. And so the idea here is, okay, I have this dictionary that's like squished into a single value. What is a way that I can break this out so that the data is more directly accessible? So my idea, one of the ways to go about this is for every single key in headline, just turn that into a separate column. So here you see we have like main, we have kicker, we have content kicker. So instead of having just one column here, one way that I can go about this is I can have, 1, 2, 3, 4, 5, 6, 7. I can have 7 columns, each having the associated value in this nested dictionary. So I'll turn one column into 7 columns. And that's kind of the process that I'm going to go through here. Again, maybe you don't want to keep all 7 columns. Maybe I only want to keep like the main. That kind of makes things a little easier. You can do like a .apply or a .map function to break that out. But yeah, just going to walk through like a quick process of unnesting a nested dictionary in a data frame. So really quickly, what I'm doing here is I'm first going to get a list of the dictionary's keys, right? I want to know that there's main, kicker, content kicker, because these are going to be like my new column names. And then I'm also going to keep track of all these new columns. This loop and what we're doing here, just really quickly, let me just separate this real quick so it's easier to look at. All right, so for key and keys, what I'm going to do is I'm going to make the new column name first. So the new column name, just because I think there might be clashes with, or just in case there are clashes in the column names, I'm just making the column name headline something, just because I'm nesting out this headline column. I just want it to be, easy for me to remember, okay, this is something that I broke out from the headline column. So therefore, what I'm doing here is I'm just renaming each column headline underscore whatever the key was. So this is just creating the new column name. And then I'm just going to add to that new column. So you can see here, I'm having this data frame. insert the new column. That's the way that we create the new columns in our data frame. And then I'm going to map from the headline. And I'm just grabbing the key from the headline column. Feel free to like break this up and also find your own way to do it if you'd like. But if we take a look at this now, if I'm looking at the new columns, this is what we have. So dot head, actually we don't really need dot head. There's only like 9 rows here, but yeah. So as you can see, this is the main headline now. Most of these turned out being null values, which is great. But yeah, as you can see, this is just a really quick way to break out my nested dictionaries. This only looks like this because I'm subsetting for that list of new columns. But as you can see, if I print out my full data frame will have all of this information unnested. You can choose to maybe like drop this column if you like, so just now repeated data, but really up to you and depending on what your analysis is about. All right. So that's transforming a nested JSON into a data frame. And, depending on how nested your JSON is, you might have to do that multiple times. Okay, so the last thing we're going to talk about is outputting a JSON. This is actually really, really useful if you want to take a dictionary and use it in a different notebook, for example. So very similar to how, in Pandas, we had our read CSV and we had our to CSV. We can do that with JSON files as well. Kind of similar with like that open file method. But instead, if you remember, we had the file name, R for read. When we want to write a new file, we have the new file name and then W for write. And then we use a JSON.dump to dump all the information there. If I run this, you'll see that seconds ago, we have this new JSON file here. I mean, right now it's the same thing because we didn't really adjust this file, but that's how you can save a JSON file. Let's say I'm done working in this notebook. I want to like take that JSON file and work in a brand new notebook, maybe do a different analysis. I can do that then. Awesome. So that is basics of JSON, just basically giant dictionary, getting used to working with very nested structures. I think we all got some good practice doing that back in like topic 3 anyways. At this point, questions? All right. So moving on to APIs. The connection between JSONs and APIs, as I mentioned at the start, when you get data from an API, it's usually in a JSON file format. So that's kind of the connection there. So what exactly are APIs? API stands for Application Programming Interface, and is basically what allows everything to play nicely with each other. An example that I like to use is if anyone remembers that Pokemon Go app, where basically you have, I don't know, you just walk around in the world and like catch Pokemon. That app actually does make use of APIs. I don't know exactly what APIs they use, but I can imagine that they were trying to get data on where the Pokemon were in the real world. That is probably queried through an API. The map data, the layout of where you are, probably some sort of map API. The whole idea is APIs allow you to get data live from other places without having to store everything. So with that very, very simple, and this is an oversimplified explanation of what's going on. Instead of having, the map of the entire world stored on your app on your phone and like all of the, the timestamps for when things are going to pop up, instead of having all of that saved, you can just keep live querying an API, and the app can run through, interacting with a bunch of APIs at the same time. For our purposes, we're probably going to use APIs mostly for getting data. So a lot of companies provide public access to their data through APIs, and that's one of the main ways that we make use of APIs. So what's an API made of? We'll actually see each of these components as we work with an example of the New York Times API. I know that the lab also is New York Times API, but we're going to work with a different New York Times API. We'll see in a little bit. But parts of the API, we have access permissions. Are we allowed to get the data? Most APIs have some tiered level of access. One, because a lot of companies do monetize their APIs. So if you sign up for like an account and you get a specific like user ID, you'll have access to like more data. Excuse me. A lot of APIs have, excuse me. Where was I? Right. A lot of APIs have limits to how much data you can get. The one that we're going to use, we won't hit the limit very likely, but sometimes, you can't have unlimited access to data. But you can see that your access permissions might change if you hit certain limits. Like, for example, I know that I think for the Reddit has an API. And if you try and like get all of their information on like all of their subreddits, I think if you exceed like 300 subreddits within a minute, they will throw you an error saying that like, hey, you're trying to get too much data all at once. So that's where you might run into things like that. If you use like a wrong API key or password, you might also run into access permissions issues. So that's access permissions. Next, we have request and response. Because APIs, for our purposes mainly, it's about getting data. It's like a two-way street, right? We make a request for data, and there are different parameters in which we can make these requests. As you can see here, there are different methods. Methods are basically what are the kinds of questions that we can ask about our data, and then also different parameters. We'll talk through this using the New York Times example in a little bit. And then finally, we have the response. After we ask for data, the response is just what we get in return. All right, so APIs are actually way more complex than this. There are a lot of APIs out there that, it's not just about getting data. Sometimes it's also about using some functionalities of a company's product that can also be in the form of an API, but we won't get too much into that. Right now, I think the main goals for right now is to understand that, APIs can let us interact with third-party software or services, i.e. data. APIs have requests and response. We're going to make requests and we're going to get responses. And then also there are different access permissions. All right, that's a lot of information. But let's talk about the New York Times API. The New York Times API, I think, is one of the more organized APIs out there, because APIs are something that I feel like companies are not, and they don't have to do this. And so sometimes companies don't prioritize making their APIs very user-friendly. But New York Times is one of the nice ones. And if we're doing different projects, we can talk about, there's like a bunch of examples of good APIs that we can talk about in the future. So just to show, actually, let me just show you all what the New York Times API has. So developer.newyorktimes.com is where you can access the New York Times API. Usually, if you are curious if a company if you're curious if a company has an API, you usually just Google for it, and it usually comes up with a URL like developer dot something. Like I know Spotify is like developer.spotify.com. So something that's more recent, New York Times has really, really good COVID-19 data as part of their API. But if we take a look at all of the APIs that they traditionally had, there's quite a good amount here. You have like top stories, you have movie reviews, and this is the one that we're going to look at, bestsellers list, article search, their archives for articles, a lot of good stuff here. And I've actually had students do projects on one of these other APIs from the New York Times. So this is all that New York Times has to offer. And what we're going to focus in on is the movie reviews API, and we'll break down documentation a little bit. But all right. So this is the schema for that. Not so important right now because we're going to pretty much explore in a little bit as well. And then I linked the documentation just in case. So let's talk about how we can get a really, really quick, how we can get an API working really quickly. So the requests library is what we're going to use to send API requests through Python. So there is actually, Python actually has its own its own way of interacting with APIs, but I think it's less user-friendly. I personally, like, I learned through the request library, so I've never used like the Python built-in one, but this is what you would use. So let's import request really quick. And the way that you make a request to an API is with a .get method. It's actually pretty neat. And what is kind of inconsistent, but I think is a really, really good thing to practice, every API's documentation looks different. So if I go into the movie reviews API, this is the main page that when I first click into movie reviews, this is what it looks like. What I like about this is that there are a lot of examples. So if I have, let's just pull this example call. I think this is actually what I have over there. As I take this example call, I'm just going to copy and paste it into the .get. Let's copy and paste that there. And let's run this. So what has happened here is the .get method has helped us to make a request to the New York Times API for data. If we take a look at just this URL and what this URL has, you can see it says, it's all right, movies, reviews, search, query equals to Godfather, an API key we'll talk about in a little bit. But I think, let's see if it actually explains what this is. Yeah, example call, but we can sort of like infer that this call should get us movie reviews on The Godfather. So this has been run, but let's take a quick look at response.txt. So response.txt, and there's actually different ways of doing like response. So response here, if I just do response itself, it actually gives us a 401. What is a 401? We'll get into that in a little bit, but usually you can do response.txt. Other options are response.content, and we'll explore this in a little bit as well. But now the response has given us a, oops, oh no. Response. Okay. So this has given us a 401 code. If anyone has like seen like error 404 or like error 401, 403, this is the same thing as that. So let's just really take a quick look at what 401 means. I mean, based on what we saw earlier from like the .text, we can kind of guess, but let's take a look here. Let's look for 403. So 403, and let's zoom in a little bit. Forbidden. So the request contained valid data and was understood by the server, but it was refusing action. So due to user not having necessary permissions. So something kind of similar is like we were just unauthorized to get this data. Data was there, but we were not authorized to get it. Cool. Now that we know that, let's try and solve this problem. So if you're unauthorized to get something, most APIs have most APIs need you to sign up for their service. A lot of them are free, some of them are paid, but you pretty much need to sign up just so that no random person can just, keep getting data. So to do that, it really depends on like site to site, but for New York Times, you basically you have an account and then you create an app. And whenever you create an app, they give you credentials basically. So for the New York Times, I know this just from like reading documentation and doing a little bit of Googling, you have to use an API key in your query. So I just know that I have to copy this like convoluted string here. And we can sort of guess, because based on this response, at the very end, it said API key equal to your key. If I were to just copy and paste my API key at the end here, let's see what happens. Let's run this. When I run this, cool, I get a response 200. Let's just take a really quick look to see what 200 means. The response 200 says, okay, perfect. Standard response for successful HTTP requests. Awesome. So I have some information there, hopefully. Before I move on into like talking about what's in this response, I do want to take a quick little segue to talk about API keys. So this code that I put here is what allowed me to get information from this API. But New York Times needed me to like sign up, make an account. I actually have like an email and password, combination to get in and get access to my keys. So this is likely not public information. If you're working on a project and you put it on GitHub, that kind of becomes public information, right? When you go onto your GitHub, you can look at your labs, you can look at like whatever was up there, whatever you had forked over. And so if I were to take this notebook and push it up to GitHub, people will see my API key. If someone just runs my notebook, they will technically be using my account, which is not a good thing. There's like a spiel here on like, should you publicly have your passwords on GitHub? The answer is no. There are actually some companies that will scour GitHub for any like accidentally published API keys and have you take your repo down. So you got to be very, very careful about that. Basically, you can just assume that people out there are not great and are just going to use your API key for like malicious intent, stuff like that. So therefore, we should not have our API keys visible on our notebooks or on our like Python files. So how can we get around that? There are several methods to do this. In your labs, it goes through this method of creating like a secret file on your computer where you store all of your API keys. So feel free to look at that, but I'm going to walk you through a different method in what's called a config file. So a config file is basically a file that you create within your repo or within, wherever it is that you're working on your project, so that your Jupyter notebook or your Python file can read in your password from somewhere else. So as a really, really quick example, how you do this is through creating Python files. So really quick way to do this, you can do this in other methods as well, but what we're going to do is just going to create a new Python file. Python files are different from notebooks. That's something that's very important to distinguish between here. We're not going to create a new notebook. Here, we're going to create a new text file. As we work through more projects, this is going to get a little bit easier to understand. So what's pretty neat is if you just change the file extension, it will change it automatically for you. So the default name for a password file is config.py. So .py, the .py, that's what signifies that it's a Python file. So anything here will read like a single cell in your Jupyter notebook. What I'm going to do here is I'm just going to save my password as a variable. So I think I hope I have that copied and pasted already. But what I'm going to do is I'm just going to call ish key equals to paste this as a string. I'm going to have this here, save that, and I just did I did a command S save. I'm going to save that and close it out. As you can see, this is my repository and my config file lives right here. And then my notebook is here. So let me just take this away so it's no longer there. Rerun this. It should be a 401 response again. All right. So what I'm going to do here is I'm going to import it. So one thing the way to do that is from config, import my key. And if you remember, the variable that my key was saved under was called ish key. So I'm importing it from the config file. And you don't have to do config.py. It just knows to look out for a Python file. So this is great because now if I look at ish key, you can see that it's actually the string of my password. So this just allows me to use the variable name ish key instead of typing this whole thing out. So cool. That's just one of the ways that you can store passwords without having your passwords being visible. So one way I'm going to do this is I'm going to take the exact same query that we had before, the exact same URL, and I'm just going to format this here. This is in a dot format for some reason. I mean, I think now the method that people do it is just like that. And I'm just going to make that into an F string. I mean, it doesn't matter the way that you edit this string. But if I do this response, and then let's just check real quick that it worked. Awesome. It was a 200 response. And now let's finally take a look at what we have. And the way to do that really quickly, because we know it's going to be in a dictionary-like format, we're just going to do response.json. Response.json has all of my information there. Cool. So this is basically going to be movie reviews on movies that match the title or match the search query Godfather. So you can see here, seems like this first one was The Black Godfather, The Godfathers of Ganja, Tokyo Godfathers. Cool. A lot of movies with the name Godfather in it, but you know, we got some results, which is what we wanted. Okay. So let's just get more specific with creating requests. This was just, you know, this is literally the example that was on the movie reviews API over here, the example call, and we got that working. So now we know that we have the ability to access New York Times API data. So let's just get more specific and get specific information. So as an example, let's just say, oh, this I forgot to update this, but let's just say we want to get movies released in 2021. So it's been 4 months and we should get a good amount of movie reviews. How do I even start constructing this? How do I start constructing this URL? You look at the documentation. So let me close this one out real quick, and I don't need this either. Okay, so every API's documentation is unfortunately structured a little bit differently. Paths is usually what the requests can be formatted like. So here, basically, there's like critics and then reviews. So critics, I'm guessing you can get like the names of movie critics, I'm assuming. And here you can get the reviews. And within reviews, there are different ways to do it. I don't know what type is. Get movie reviews. Not sure what that is. And there's also a search function. So this is really, it comes through experience of just using a bunch of different APIs, but I know I'm going to use the search function. It's a lot of trial and error as well, and like messing around with like response codes and like different parameters, but here's how we can start. How API request URLs are structured, and actually the right name for that URL is actually a URI. So I think I have that somewhere. Never mind. So this is called a URI. If it's a URL is more for like, it returns you a web page, you know, is what you literally have up here. But these are called URIs, which stands for Uniform Resource Identifier. So the way you structure that is you have a base URI. So usually they make the base URI pretty visible somewhere on the page. So this is our base URI. So there's a base URI, and there are a bunch of parameters that you can add to it. The format's like this. As you can see, it ends with search.json. So the way that you format it is search.json. You add a question mark to start your different query parameters, and then you can add as many parameters as you want. So right now, based on this, I know that I only want to get movies released in 2021. Let's just see what parameters are available to us. There's critics pick, there's offset, opening date. That's probably one we're going to use because we care about movies that were only released this past year. There's order, publication date, maybe a specific reviewer, a specific query. So cool. Now I don't really care what kind of movie I want to get. Right now, I just want to get like all movies that were made in 2021. So this kind of tells you how to format it. So it's a string and it's a US opening date range, start and end date separated by a colon. Cool. And in this format of like year dash month dash day. So cool, let's do that. Here I just do opening date equal to 2021-01-01, and then I add my API key as well. There are many ways that you can format this string. The whole point is you just have to get, you know, the URI in the way that the .get wants it. So I'm doing a couple of different ways here. Here I have my URI looking like this, and it ends in API key equal to whatever. So this is really just the string. And so if I take a look at URI, it ends in API key equal to whatever. When I make the request, that's where I'm just putting the two strings together. I'm just going to add my API key at the end. So if you see here, when I do my request.get, this is one way to do it. I just have my API key at the end. I can just do, you know, URI plus key looks like this, but, you know, it just won't show up. So that's what I'm doing. And then I do my .json as well. So let me just run this one first. Cool. I have some results, and let's take a look at what our results are. Awesome. The date range should contain start and end dates separated by a colon. Okay, so let's just add an end date real quick. Let's see, opening date. Okay, 2021, and today is 05/05. Hopefully this works now. Here we go. Huh. Sorry, y'all. I don't know why this isn't working. Oh, there we go. Awesome. Little typo there. Okay, so we have our results now. And I said that I shouldn't be I should be displaying all of this, but through this and through like exploring the keys, just for the sake of time, I know that what I want is actually in the results key. So what I want is in results, and this is a list of my results. So therefore, that's why I have here the length of results is 20. So just like that, I have 20 movie reviews. Let's just take a quick look at the keys here. I have display title, MPAA rating, critics pick, headline, all of this information. And let's just throw that into a Pandas data frame. I think I'd already imported this, so cool. So just like that, I have a data frame full of reviews. I have like the headline, I have like the name of the movie, opening date, and you can see this is literally last week, I think. So pretty neat. So just like that, we have 20 reviews saved in a data frame. I can even export this as a CSV, so I have it locally forever. And yeah. Any questions at this point? All right. The last thing we're going to talk about is pagination and offset. So what I have here is 20 movie reviews, but ideally I would like to get more. How can I get more? So somewhere in this documentation, it tells you that you're limited to 20 reviews per API call. So every time you make an API call, you only get 20 results. But obviously there should be more than 20 pieces of data that exist in their database. The way to get more data is by using pagination, and pagination is basically the act of putting things together, and offset. And offset is the parameter that we saw earlier that allows us to start our new search result at a certain number. So we just take a really quick look at the offset parameter in the documentation here. A lot of APIs do have this similar offset parameter too. So this is something that's kind of consistent. You can see that it's an integer, must be a multiple of 20, and it is used to paginate through results. And apparently there's a has more field that indicates that a response has more results. So cool. Let me just copy the URL that I used over because I know I just changed it. Okay, awesome. So I just am setting this new URI to, and then to add an offset, I'm just going to do ampersand offset equal to 20. And I'm doing 20 because it must be a multiple of 20. So what the offset equal 20 means, it means that I'm going to start pulling my results at result number 20. So, I have 1 through, well, I guess 21. I have 1 through 20 already. This next call will give me 21 through 40. So I have this exact same thing. I'm going to run the code. The only thing I've added is this offset equal to 20. Let's just see what we get. Cool. We have more results. As you can see here, and let me just put that into a data frame real quick. pd.data frame results to results. Awesome. As you can see, these movies are different. I think the first one there was Mitchell's versus the Machines, and the first one here is Monday. And as you can see, the opening date kind of like has been decreasing. So you know that these are our next set of results. So just like that, we've gotten the next 20. So the act of pagination is just going through and getting, subsequent sets of results and just putting them together. And there's no automated way to do this. You just write your own loop to do that. And so what I have here is a okay written function, not the best way to do it. And I'll talk about why in a little bit. But the whole idea of this, as you know, the only thing that we added here, the only thing that we adjusted was the number in our offset. We just added this offset parameter. I'm just going to keep this as 2020. Hopefully that works, because this was 2020 when I created this. But basically what I'm going to do is I'm writing this loop, and the loop is going to loop through and help me get X number of however many results I want. This is not the best written function because I guess I got a little lazy and I put n, where n by 20 is the number of reviews that we want. So if I want to get 100 reviews, I put 5. Of course, I could just change this function to, match it a little bit better, but in the interest of this is easier to read and easier to figure out, this is what we have. And so what we're doing here is for I in range 0 up to n. So if n was 5, it will be 0, 1, 2, 3, 4. If I is not equal to 0, and I'll talk about why I had to do that, basically just add offset being like 20, 40, 60, 80, 100. Why I had to do I not equal to 0 is just for some reason, if I had offset equal to 0, the result wouldn't, it would give me still like an offset equal 20. So I don't know why that was. And then what I'm doing there is I'm just putting all the responses together. So as you can see, I'm doing the .get for the different URIs. If it's okay, add the results to my results list. Hopefully this still works. And let's just quickly get, let's see if this works for 60 reviews. And actually I have it return the whole data frame as well. Okay, I thought so because they kind of changed the opening date thing. Let me just quickly grab this. It used to be that you didn't have to put an end date. Let me just grab this real quick. Okay, hopefully this works now. It's going to take a little while, but there we go. Just like that. I mean, we saw this already. The Mitchells versus the Machines was the first one. And then we have, I think, Mondays at some point somewhere. Let's see. What was it called? Okay, I guess it's different movies now. But anyways, yeah, this is how I just was able to get a bunch of different movies all at once. I'm just curious as to what was the one that was there before. Oh, Monday and In the Earth. Maybe in the last bit of time has changed. Anyways, not super important. The fact is we just got a bunch of reviews. So let's say I wanted to get 100 reviews, or let's do a little bit more. This would give me 160 reviews. So just with this function, and I did it for one pass and I just put it in a function, put it in a loop, I'm able to get all of this information and I can do all sorts of analysis on this stuff now. Awesome. So with that, does anyone have any questions?
I do. In regards to the config file, you mentioned that if you upload it to GitHub, that people can actually look at it and stuff like that. Is there a way to keep that particular file private?
Yes, that's a really, really good point. I was actually going to talk more about that when we get to our projects, but I don't remember if I mentioned the Git Ignore file yet.
You did. I
remember.
I vaguely remember. I don't think I've ever had to use it, so it's kind of
perfect. Okay, so let's just talk about that super quick. This is our study groups repo, and most repos have a Git Ignore file. And when we get to our project, I talk about how to create it. So in the Git Ignore, what it does is basically any file that matches a name in this Git Ignore file, and it's really just like a list of file names, it will not push that said file up to GitHub. So in here, you can see that config.py is here. So
Okay.
automatically when you do like, your git add commit push, your Git will kind of scan all your files and be like, okay, this config file, the file name exists in the git ignore, so we're not going to push that file up. You might say like, okay, then that means not a random person won't be able to clone my repo and work on it, but that's kind of the point as well. So yeah, you're gonna add to your git ignore.
Okay.
Cool. Anything else? Awesome. APIs are a lot. And so like, I feel like in an hour or less than an hour, because we had to talk about JSON for a bit, it's kind of hard to get through all of the details, but it's very much like example by example thing, because every API is slightly different. A lot of the structures are similar, but every documentation is different. The parameters for every API is going to be a little bit different. So that's just something to keep in mind. Also very quickly, just to end off, the way that you can incorporate this into your upcoming project is you can augment your data set that we provide. So just as a sneak peek, the project, we will give you a bunch of data. Feel free to augment or replace data through an API. And when we get to the project, I will have like some recommendations of APIs that you can use for the project. All right, I'm going to stop the recording.